In this video, we're just going to talk about dividing radicals. It's called dividing radicals to sum because we have like this fraction bar, right? I guess that represents division. But essentially when we talk about dividing radicals, we're taking a radical, dividing something else, and we just want to make sure that when we write our final answer, that we have no irrational numbers in the denominator. Right, so a fraction is made up of the two parts. You've got the denominator that's always the bottom, and then you have the numerator on top. And we just want to make sure when we're done that there are no irrational numbers down here in the bottom. So that means square roots we don't want in the bottom, right? When we get to imaginary numbers, we don't want those in the bottom. So we just want to make sure there's a nice whole number in the bottom of our fraction. And then it's a fraction, so if we can simplify, we're going to simplify. So there's a couple different cases that we can run into and different strategies to help us attack those. The first one is if we have a radical in the bottom, we see if we can just simplify it all the way first, okay? So notice this one, we just have 64. Well, the square root of 64, right, is 8 times 8. So really, that's just 3 times 8, which is 24. That simplifies very easily because the radical has a whole number square root. On the top, you still have that 4 square root of 2. And if I could, I would simplify the square root of 2 at this point. But that does not simplify at all. So my last question is, now that I'm done with the radical parts, can I just simplify the coefficients? So is there anything that divides out of both of those, just like we would simplifying a fraction? Well, both of those are divisible by 4. So this would become a 1, and this would become a 6, because 4 goes into 4 once. 4 goes into 24 6 times. So this would look like 1 square root of 2 over 6. And this would be our final answer. Now, again, be very careful. It looks like, right, 2 and 6 can both be divided by 2, but remember, this is the square root of 2. So he's inside a radical, just like when we multiply coefficients or these whole numbers, they can't go into the radical. So that would be as simplified as it can go. Okay, I'm going to jump down and look at number 9 just to give you a second example. But first, notice if we look at the next example here, before I jump down to number 9, this one's different. So when I start to try and simplify this one, the 10 does not break down into something that creates groups and goes away. So this one we need to get rid of. Now, we use a strategy by, it says up here in step 2, if there's still a square root in the denominator that's a monomial, you're going to multiply it basically by itself. So, for example, if I take this and I multiply him by the square root of 10, I need to also multiply the top by the square root of 10. Now, why did I choose the square root of 10? Well, the reason is anytime you take a square root, so if I were to take the square root of 3 and times it by the square root of 3, I get the square root of 9. But you've just forced yourself to get a whole number square root, right? That just ends up being 3. So when we multiply something by itself, it's like squaring it. And the opposite of a square root is being squared. So you're sort of undoing that square root. So if we did the square root of 7 and we times it by the square root of 7, you get the square root of 49. Well, the square root of 49 is 7. So anytime you multiply a square root by itself, or in other words, square that square root, it gets rid of the square root. So for example, up here, we have 3 on the bottom times the square root, 3 square root of 10 times the square root of 10. That's the square root of 100, right? Well, the square root of 100 is 10. I'm going to write these out in all the steps so you can see kind of where I'm thinking here. That ends up just being 30 on the bottom. So we choose a radical, and it's always, always, always the radical piece that we need to get rid of times itself. Okay, and then because we multiplied the bottom, you also have to multiply the top by that same thing. So on the top, we're going to have 5 root 2 times square root of 10, so we have 5. We multiply the radicands together, 2 times 10, we end up with 20. And then again, if I can simplify radicals, we always go down as far as we can. So 20 would be like 5 and 4, 2 and 2, and we have a group of 2 there. So in this case, we've got 2 square root of, they've left over 5. And I'm just going to move that over here because we kept simplifying the bottom. Now notice you're almost done. You just need to ask that same question we did in the first one. Is there something that divides out of both coefficients? Oh man, I did it wrong. I apologize. Let's take it back. Let's take it back. Don't forget, there's already a coefficient out front. So we can pull a 2 out, but there's already a 5 out there. So we want this to be 10 with the leftover 5 there. Very good. 10 square root of 5. Sorry about that. So in this case, again, we ask that same question. Can something divide out of these two coefficients? Well, they both end in 0. They're both divisible by 10. So 10 goes into 10 once. 10 goes into 33 times. So we're going to have 1 square root of 5 all over 3. Okay. I'm going to jump down to number 9 just so you get another example that's similar. Number 9, we've got 2 square root of 3 all over 6. So again, we would want to say, well, the square root of 6 is stuck in the bottom. It doesn't simplify on its own nicely. So we're going to multiply by the square root of 6. And if we multiply the bottom by that, we have to multiply the top. So on the bottom, I'm going to have the square root of 36, or in other words, that simplifies 6 and 6. We just get 6. On the top, I'm going to have 2 times the square root of 3 times 6 is 18. Again, 18 is probably one we can build a tree with. So 18 would be like 3 and 6, 3 and 2. We've got a group of 3 there. Again, there's already a 2 out front. So 3 times 2 is 6. Square root of that leftover 2 there. So the 6's go ahead and simplify there, right? And we're just left with the square root of 2. Awesome. Okay, I'm going to give you one more example just because it relates to one similar that you guys will do on your homework. If I have, let's say I have like 3 plus, nope, I'm going to change it, sorry. I'm going to do 2 plus 2 square root of 3. All over, let's do 3 square root of 6. Okay, if this is what I'm looking at, again, there's a square root of 6 there stuck in the bottom. So the only difference between this one and the other ones is there's 2 terms here on top. But again, the goal is to get the radical out of the bottom. So I don't really care what's happening up here. I just need to get rid of that square root of 6. So I'm going to go ahead and multiply by the square root of 6. Now again, I don't need to get rid of the 3 necessarily, so I'm not including that 3 out front, just the square root of 6, and anything we multiply by the bottom, we do to the top. So on the bottom, I go ahead and do 3 square root of 6 times 6, which is 36. But that's, right, the square root of that is just 6, so 3 times 6 gives me 18. On the top, remember that you're multiplying both terms by the square root of 6, so I like to put parentheses around it to help me remember that. And then I need to distribute this. So 2 times the square root of 6 would be 2 square root 6. Then we distribute to this term, so 2 root 3 times the square root of 6 would be 2 square root of 18. And again, we just looked at 18 can break down, so 2 and 9. 3 and 3, we've got a group there, so this guy can come out with the 2. This would end up looking like 6 square root of 2 there on the end, and then that first term again was already simplified, so we've got 2 square root 6 plus 6 square root 2 all over 18. Again, before we're done, we just ask the question, is there anything that simplifies? But notice you have 3 terms, and well, you have the 2 terms on top, so you can't just look at these 2 numbers, you have to look at all the coefficients. If it divides out of all of them, free game. If it only divides out of 2 of them, then you can't do it. It has to divide out of every coefficient involved. So here 2 can divide into 2 once, can divide into 6 3 times, and into 18 9 times. So we end up getting the square root of 6 plus 3 square root of 2 all over 9. Now again, it's tempting to look at this and say, well, what about 3 and 9? But again, it has to be common to all 3 coefficients in order to come out. So this one we would be done with at this point. Okay, in the next video, I'll talk about what to do if there is a binomial in the bottom, something that looks like that.